All right, let's get started. Today we're going to continue talking about economic equivalence, which remember is how we keep track of the time value of money and how amounts, for example, at the present can be translated into amounts in the future. So we're going to do two different ways of calculating time value of money problems. One, the table lookup method, and one, the equation method. So I've just given you this handout with the formula sheet on the front, a couple of related information things in the middle, and then several different tables for different interest rates where I'll show you how to use these in today's class. This is taken from the reference manual that's provided for the Fundamentals of Engineering exam. So it's the same resource that you'd have available when you take the FE. I think it's good for you to become acquainted with what the formulas are going to look like during that test, since it's timed and the pressure is high and you need to be able to work through things quickly. Just a reminder about the next homework assignment. It's due a week from today on September 4th, and we won't have class next Monday, so we'll meet today and then Friday of this week, and then our next meeting after that will be Wednesday. Yeah. Okay, so this is the equation sheet that I gave you, and at first glance it's a little bit difficult to see what the formula is because they're only in the formula column showing you what is the right-hand side of the equation. But the way to understand it is that, for example, for the first row where it says f/p I% comma n, this is that standard notation that we talked about in a previous class where a word problem can be distilled down to the information that's in the parentheses here. So find f given p at some interest rate and for a certain number of compounding periods. So the way that you'd interpret that is f divided by p equals 1 plus I to the n. And that's very similar to what I've written on the board on prior occasions when I said f equals p times 1 plus I to the n. So you see, all that they've done is they've just said, let's move the p term to the left-hand side of the equation so that what you're calculating is a ratio. So the right-hand side of this formula column, for each of them, it's a ratio. So the way that we would write, for example, A/P. So the formula there, A divided by P is equal to I 1 plus I to the n divided by 1 plus I to the n minus 1. So in each case, it's just this first ratio inside of the brackets is equal to the term that's in the formula column. And some of these formulas get pretty complicated if you look at what you've got to do for gradients. But you'll get good at putting these through your calculator and getting the equations. The nice thing is that when you're using the interest factors and the equation method, is that you can have absolute precision where your calculations will be to the nearest penny. And that's in contrast to when you're using the tables that are in the last part of this packet. We'll talk about why you can't have perfect accuracy with those tables. So any questions so far on how to use this interest factor equation sheet? There's different names here, capital recovery, uniform series, and so on. It kind of summarizes find A given F, find F given A, and so on. And then the symbol is just a reminder of how you would summarize a problem of that type. Here's what the tables look like. And this is actually scanned from a textbook, although the font is a little bit different and maybe the order let's see, yeah, the order of columns is different in the handout I've given you compared to the screen, but the numbers would be the same for the 8% table. And the way that you apply these is the same. So what it's basically telling you is that if you're solving a problem where the interest rate is 8%, then this is the table that you'd use. And so there's a different table for each interest rate. And if you look at the handout I've given you, there's a 4% table, there's a 6% table, but there isn't a 5% table here. So you just have to find a book or a resource that did have the 5% table if it wasn't provided and you wanted to use the table lookup method. This semester on the homework, I'll specifically tell you when I want you to use a certain method. Whether it's a homework or an exam, sometimes I'll say use the table method, which means use this. Sometimes I'll say use the equation method, which means do this. And if it doesn't specifically say, then you can choose which method to apply. So I'll be explicit when I have a preference. Otherwise, you choose. The way this table was generated was they used the formula and they calculated with I for 8% and N for each row, what would be the ratio of F/P. So let's just prove that to ourselves. Because we've got the 8% table on the screen right now, let's let I equals 8%, 0.08, and if N equals 1, then what is F divided by P? All right, it would be 1.08 to the power of 1. So therefore, F divided by P is 1.08. And that's what they've got here, 1.08. Let's not do it for all of them, but let's just say, what if it's N equals 7? Okay, so for N equals 7, F divided by P, according to the formulas that we've got, would be 1.08 to the power of 7. Anybody have their calculator handy today? Help me out with some number crunching. Double check, because I'll do it, and I want to make sure that I don't type it in wrong. 1.08 to the power of 7. Okay, so I got 1.71382426, and so on. Okay, good. Did they write all of those numbers? No. They know that they don't have unlimited space, and each digit is getting progressively less significant the longer it goes. Like the most important digits are the ones that are closest to the decimal. These ones far, far, far away probably aren't going to matter unless we're talking about like trillions of dollars. So for N equals 7, they said 1.7138. So we've got that, 1.7138. There's other numbers that they haven't shown. So if we apply the table lookup method, we have to round off to the number of digits that they've included. So they've included here 1, 2, 3, 4, 5. So if I was solving a problem and it was given that P was $65,000, 123.45. So that's 1, 2, 3, 4, 5, 6, 7 digits in the amount. And I want to find out what is F. So like the kind of problem this would be is you deposit $65,123.45 now into a bank that pays 8% annual interest. How much can you withdraw as a single lump sum in 7 years? So in 7 years, how much can you withdraw? That's the kind of word problem that we're doing here. In this format, we'd say find F given P, for an interest rate of 0.08 and n equals 7. That's how we kind of summarize the kind of problem this is in the brackets defining what's the unknown, what's the given, the interest rate that applies, and the number of compounding periods. All right, so what is F? Okay, F is going to be, if I'm using these digits, 1.7138 times 65,123.45. Okay, let me get my calculator, and if you'll also do these same calculations. And this is important because we're not going to cover round off over and over this semester. We're going to do it once or twice, and then I'm just going to expect you to know it and do the appropriate thing. So 1.7138 times 65,123.45. All right. So my calculator says 111,608.56861. My calculator says all of those digits. My calculator doesn't know that this factor should have been longer than it is. I have to know that and round things up. So when I've got a factor with 1, 2, 3, 4, 5 digits, then that means my final answer should be rounded off to that same number of digits. 1, 2, 3, 4, 5. So the nearest $10. So the actual answer here would be 111,610. That's as accurate as I can be when I'm using a 5-digit factor. 111,610. Now, if I calculated my own factor using the equation method, then I could be accurate to the nearest penny. If I'm using this 1.7138242268 and so on. Okay. So anybody have questions about this illustration on either how to round off or how these were calculated? Like this table was calculated using these formulas. So for example, this F/A column, they call it compound amount. How did they come up with these numbers for the F/A? They used this equation, and they just, for n equals 1, they calculated what's the factor. N equals 2, calculated what's the factor. For all of those being the same interest rate of 8%, they used the equations to calculate these tables. And so sometimes it's just simpler to use the table if you're in a rush rather than applying the equation method, especially for some of these gradient equations. You have to know how to do both. Okay, so let's just look at some additional illustrations here. A person deposits $5,000 into an account which pays interest at a rate of 8% per year. It doesn't say when they deposited the $5,000. You just have to make the most logical conclusion that if they don't mention when it was deposited, that is by definition when this whole sequence of events kicks off. That means it's time 0. That's a present. So 5,000 is P, I is 8, N is 10, and it never says the word compounding here. It doesn't say the compounding is annual, but they don't say anything about compounding being at a different frequency. They don't say monthly or daily. So annual is the default assumption if nothing else is mentioned. So with annual compounding, N equals 10. So the amount in the account after 10 years is closest to which of the following? So what we do is sometimes just to help us set the stage, you can always draw a cash flow diagram. And even if a problem doesn't require you to draw a cash flow diagram, sometimes it's definitely time well spent. If it's a complicated sequence of payments and receipts over time, it can really be, like 15 or 20 seconds well spent if you sketch it out just to keep it all straight. So here the cash flow diagram is deposit $5,000 now, 10 years later, how much can you withdraw at 8%? So if we were using the 8% table, and you've got the 8% table, I just handed it out. So n equals 10. This is find F given P. So that's the F/P column is in the middle. So 2.1589 is the factor ratio. So that's the ratio of F to P. So if P is 5,000, then you multiply 5,000 by that ratio. And which of these is that going to be closest to? That's 10,795. So answer C. The Fundamentals of Engineering exam, which hopefully everybody here takes, they write it so that each problem should take less than 4 minutes to solve on average. Some of them are a little bit longer, some of them are shorter, but these are like those perfect kind of 3-4 minute type problems, because you got to read the statement, think about it for a second, flip through. Well, actually, it's not a paper manual. When you take the FE exam, it's a PDF that's searchable. So you just search for the phrase interest rate tables, and there they are. And you can solve those pretty quickly. All right, so let's take a look at another example, and I'm going to turn you loose on today's in-class exercise. A small company wants to make a single deposit now so that it'll have enough money to purchase a backhoe costing $50,000 5 years from now. Okay, so think. That is a deposit now, so that's an outflow, arrow down, but they don't know the amount now, so that would be a dashed line, P equals question mark. And then 5 years from now, they want to withdraw 50,000, so that's an up arrow, F, future amount is known to be 50,000. So how much has to be deposited now if the interest rate's 10% per year? So here's our cash flow diagram. We deposit some money now, withdraw it in 5 years. Interest rate is 10%. We have the 10% table. So this is, if you think in terms of the summary nomenclature, like inside the parentheses, you need to get in the practice of summarizing problems. So this is find P given F, I equals 10%, N equals 5. So we have the 10% table. N equals 5 is in bold. And the P/F column is the first one. So you'll see how the factor is 0.6209. So that tells you that if 50,000 is how much you're going to withdraw, you only need to deposit 62.09% of that amount at the present so that it will compound into the desired amount in the future. So 0.6209 multiplied by 50,000, $31,045. Any questions at all? All right, let me give you today's handout. I'll bring it up on screen. That's not it. That's 4, 5.
So confused, and then he said he thought that I was like, and I was like, oh, good. I'll add it to the call. Indeed it is.
Let's double check to make sure everybody's on the same page for this first problem. Let's look at the solution together. So you receive $50,000 in 7 years. What's the present value of that? Does anybody here watch Curb Your Enthusiasm? No? All right. Well, you wouldn't get the reference then, so I'll skip it. Sometimes you may have a contract where you're going to receive money in the future. Like, for example, sometimes people have lawsuits and there could be like a structured settlement where you're getting paid over time, but you need the cash now, so you just take a single lump sum today. And the question is, how much should the lump sum of money be today if you have some future revenues that you're going to receive? So this is that kind of problem where you're finding out an economically equivalent present value to a single lump sum of $50,000 in revenue at year 7. So the cash flow diagram's there. We'd summarize it in terms of this, like annotation method of find P given F. The unknown is always in the numerator of those because of the way that we use the ratio. We use the ratio to solve for the unknown, so it makes sense that the unknown would be in the numerator. What it allows us to do is once we calculate the ratio, then just multiply F, the known, by the ratio to solve for the unknown P. So here's the equation that we use. And where does that equation come from? If we look at the formulas, here is the find P given F. So P divided by F is equal to 1 plus I to the power of negative n. So that's how we can determine which formula to use. And what's the value of the ratio? I only wrote it here to 1, 2, 3, 4, 5 digits, but then I have this ellipse. It's called ellipsis. Like when you've got the dot, 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 that just is implying that there's additional precision and more numbers that I've kept in my calculator. I didn't round off inside the calculator so that when I multiply 50,000 by that amount, it's going to be accurate to the nearest penny. So 29,174 and 52 cents. Anybody else get the same value? Good. All right. Now then what this says is use the table lookup method to solve the problem. So this is 8% interest. We have the 8% table here. So 8%, n equals 7, and we want to have the find P given F, 0.5835. So 0.5835. So we have to only have 4 digits of precision there, which means that you need to round off your final answer to the nearest $10. So when you multiply 50,000 by 0.5835, the final answer should be 29,180. All right, so that one's a pretty good run through of from beginning to end, like what's going on with these factor type problems. Problem 2. Instead of a word statement, you've just got a diagram. And you're getting pretty good, hopefully, at interpreting these. You can see that the unknown is a present value. So this is find P given A. So you're going to go to the table lookup method for 8%. Where is our find P given A? It's that last column, present worth. Find P given A. Now, the handout doesn't say directly what is n. So what did you use as n? 3. Well, why not use 4? Because I see the number 4 on that figure. Why not use 4, Matthew?
There's nothing going on at 4.
Nothing's happening at 4, at 5, at 6. Just because the cash flow diagram continues a certain number of years, you have to think, well, what's the annual series doing? The annual series is there's 3 payments, so n equals 3. And an annual series, by the way, always starts the year after the present. And so if there was some amount at year 0, that would not be part of the annual series. The annual series is always 1 year after the present. So how do we solve this one? Find P given A. So we would summarize the problem type. P slash A, I equals 8%, N equals 3. Okay, we go to the 8% table. Find P given A, N equals 3, 2.5771. So that is 2.5771. So what I've done is I've said, like, everything that's happening here is equal to 2.5771. So P is the annual amount that's recurring, 12,500, multiplied by 2.5771. And I think for that one we should get 32,214. So there's 1, 2, 3, 4, 5 significant digits in my factor. So I can have 1, 2, 3, 4, 5 significant digits in my answer. Any questions about problem 2? Yeah.
Should we always round up in these cases?
Not necessarily, no. I don't remember, like, what do we get if we just multiply, let's see, so 12,500 multiplied by 2.5771. Yeah, so that one says 32,213 and 75 cents. So the reason why we said 214 is just because it's closer to 4 than it is to 3. But it's not always rounding up. It's just like the standard round off rules. And so if it had been 213 and 45 cents, then we'd say 213 instead of 214. Are there other questions? Yeah.
So this one you rounded it to 5 places because it has 2.5771.
Yep.
And the other one it was 0.5835.
Mm-hmm.
And you did it to 4 places. Is it just because it starts with a 0?
Yes.
Okay.
Yeah, the 0 is not considered any digit. It's not a digit that we're using.
Gotcha.
Yeah. Good question. Thank you. Are there others? All right, so then the last one here, problem 3, find A given P. So we just rearrange this. Find A given P. Oh, the interest rate is 11.5%. And N equals 3. I specifically tell you to use the equation method, but what if I hadn't? What if I hadn't told you to use the equation method? Well, you can go looking for an 11.5% factor table. I don't think you're going to find one. Like maybe there's some old-timey textbook from the 50s where people didn't have calculators. There might be a 11.5% factor table from the 50s, but probably not in any recent text because people would just generally use the equation method regardless of what was specified if it's 11.5%. So for that one, what I'm expecting you to do is use the formulas, use these ones. Okay, so if we have find A given P, so here's the A slash P. You want to find A, P is the known, A is the unknown. So it is I times 1 plus I to the power of n divided by 1 plus I to the n minus 1. Okay, so you substitute in I equals 0.115, n equals 3. And if you do that, remember you need to keep all of your precision. So here you can see the substitutions that I've done. It's always good to write your work in as many steps as possible. That's counterintuitive. Maybe you're trying to save time. You're trying to save, like, maybe your pen and pencil budget's just been skyrocketing. You're trying to save a little bit of ink, so you don't want to write too much. I think it's a good investment. Like, ink is cheap, pencils are cheap. So write it, don't just do it all in your calculator and only write down the final answer, because it's hard to check your work if you've only got the final answer. The advantage of this approach, like what I'm doing is I'm showing the formula, and then I'm showing the substitutions, and then like the first round of calculations is everything in the numerator, everything in the denominator, and then I show, once you divide those two, what you end up with. This is repeatable. Like, you should check your work to make sure that you got the right factor, because there's just so many ways in a formula this complicated to, for your finger to slip, for you to get distracted as you're doing your calculations. And so you should never only calculate it one time. The true engineer will calculate this 3 times to be sure, because even the second time maybe you got it wrong. So if you calculate it 3 times and it was the same value all 3 times, then you can kind of settle down and calculate your final answer here. But you'll notice it's accurate to the nearest penny. So 3095 and 82 cents. Let's look at the homework. Let's pull it up together. We've still got some time. We've got 5 minutes. So let's see if the homework is going to be a surprise or if it's related to some things we've been doing in class. Because I always hated that. When I was in school, I never liked the surprise assignments where it seemed completely unrelated to what we'd been learning. So I try to avoid that. Once in a while, I'll throw you a curveball and kind of expect you to figure something out on your own. All right, so this is the next homework assignment. How much would you have in 18 years if you deposit $1,000 today? So yes. This is find F given P. Calculate the lump sum. This is find P given F. Effective interest rates we've done. Prepare a cash flow diagram. You don't even need to do calculations for part 4. That's just the cash flow diagram. Find the present value. Yeah, these, you should be able to knock these out very quickly and efficiently at this point. In fact, the only one I don't think you can do yet is problem 10. And probably many of you could do problem 10. We haven't talked about it yet. I bet you could figure it out. But yeah. Wait, is this the same thing that we just barely solved?
It's just a different interest rate.
Different interest rate. Okay, good. Boy, I would have been embarrassed if it was exactly the same problem. All right, so we haven't got to it yet, but I simply can't resist. I just love engineering economics so much. How do you suppose you can solve this one? I say that it's a minimum of 2 calculation steps. This is not the classical annual series, is it? Because ordinarily, a classical annual series, like when you find P, it's 1 year before the annual recurring amounts begin. And we've got a big gap in time here. So how do you find the present value when the annual amounts don't start till year 4? I can tell you want to take a guess, right?
Kind of.
All right, let's hear it.
Would you not count those first 3 years?
Nothing's happening in those first 3 years. So we wouldn't consider them part of the annual series because there's no revenue, there's no outflow. So no. Yeah.
I'd say you calculate an intermediary F value
Yes.
in 3, and then you use that to calculate the annual series.
He's got it. He nailed it. So he used a very important word, intermediate. So what he's saying is, let's pretend for a moment that this is our present. So take this annual series to a single lump sum in year 3, and then once you know that, take it from year 3, a lump sum, to year 0. And that's it exactly. So that's what we're going to start looking at on Friday, is some more complicated cash flow diagrams like that. But if you wanted to finish the entire assignment right now, he's nailed it with this notion of an intermediate value that you'd find as a lump sum. So you'd call it a present value when you're finding the amount in year 3, and then you'd change your perspective and you'd say, no, actually, that amount in year 3 is a future value, and what I really want to know is the present value in year 0. All right, so that's the hint for that one. That assignment's due a week from today. That's loads of time. I'll see you in class on Friday.